In this tutorial, we're going to create an evolving binaural soundscape that places individual notes of a chord around you in a spatial setup. For this, we will learn about binaural spatialization, how to activate it and use it, as well as how to use the keyboard to tune chords to your liking and have them amplitude modulated instead of ring modulated. Okay, so please load example number 5, binaural chord space. So make yourself comfortable as usual. And so what we have here is you are surrounded by these little setups here, and they are here 6 times. So let's have a look at one setup here now. And I turned down the volume a bit more of these. So we have an oscillator, a sine wave oscillator in audio range. And this is being fed with audio, with a volume modulation from a slow sine wave LFO. Which is being polarized from bipolar to unipolar. We will discuss this in one moment, which basically makes it come and go. And then we have on the exponential FN input, two modules here are mixed together. One, there is a keyboard, 2 octaves keyboard, which I can set notes on. And there is a quantizer, which is set to octave, so that basically we can switch the octaves higher and lower. So how does this sound? I can set a note here. I can pitch it up in octave steps, very high actually and very low. Maybe go here. Turn up the volume like so, and now I go through all of these and configure a chord to my likings. So that's quite low. This one here too, I transposed it 2 octaves lower. So if you are on the built-in speakers, you can't hear it, but on big speakers and on headphones, you should be able to hear this. Right. And if you might have noticed by now, when you have been doing this as well on your setup here, the sounds are binaurally spatialized. The individual sounds are not placed mono inside your head, but they actually come from all the little oscillators here. And so with the binaural spatialization thing, there are actually speakers, virtual speakers, in most of the modules on the rear, which indicates that these can sound binaurally. And you can switch between the 2 modes, binaural and the normal stereo setup without the spatialization, by pressing the joystick on the right controller. So now it's inside my head and it's mono. It's a bit louder as well because of a volume difference in the spatialization mode. So now it's spatialized again. So the thing is, this recording, unfortunately, is mono. I'm recording this with a MetaQuest operating system recording function. Unfortunately, it is still mono. I was asking them to make it stereo, but it's still mono. So please try it out in your patch to switch between the modes in order to get the difference. And if you start a new patch, that is normally starting in the stereo mode, non-spatialized. Let me turn these down again. I was the binauralization mode is saved within the patch. So when you load this up, it's automatically jumping to binaural. That's why it was binaural from the beginning. And the other patches so far, other examples and tutorials so far have not been binaural. Right. You could also change, play with the wave shape, of course, and change the speed of this LFO. Can give this all a different character, or you could add filtering here. But so for your understanding, I want to talk a little bit more about the keyboard and this polarizer, because these are the new modules basically in this patch right now. So let's let me put these to 0. I can also just press B and tap these like so. It goes quite quick. And then I am copying this little fella here and an oscillator, and I need an AD envelope generator. So because this thing here on its own, it doesn't make any sound. It's just providing pitch information and a gate signal, pretty much like a Eurorack monophonic synth would work. So, and the pitch information you can give directly into the exponential volt per octave chromatic pitching input here. And then the amplitude thing will be controlled from this AD generator, and the gate goes in here. So now you can play this oscillator here. It's a bit loud, very loud actually. Like a little keyboard or something like that, a very simple one. And so there is, you can move along the keyboard with the notes. And well, you know about the ID, you know about the oscillator, but what exactly is coming out of this keyboard now? So let's have a look with the scope. Disconnect these again. So this is I mute the scope, because otherwise we'll be clicking a lot. So, and maybe you can see that it's a small. This is stepping this the key basically from semitone to semitone. It's 1/12 of an octave, and this is the step size then, which is compatible to the exponential FM input here. So this is that input, and then the gate signal here. This is I can turn down the sample rate. So if you hold it, then it will be on for longer. Actually, this envelope here does not support holding it. This will always be a one-shot trigger, but there's another envelope, the ADSR here, which is an ADSR, which is attack, decay, then sustain and release, which has a hold stage. So you could use this to make it more feel like a bigger keyboard. Right. So this is the keyboard, and this is what's happening here. The gate signal is not used in this patch, only the pitch information. When you press the button, the pitch information stays. It will stay on that level, and so that's how I can easily configure a chord without having to press continuously these notes and keys. Right, and then what is going on with the polarizer? We have in the ring modulation example, we have used one oscillator to drive the amplitude CV input of another one, and there we did not use a polarizer. The thing is, these oscillators here, they go from +1 to -1. So if they oscillate along their full range, like so, they go fully from +1 to -1. And these inputs here, they allow for inversion. So this is actually just a multiplication. If you put in 1, then the signal is just being reproduced with 1. If you put in 0.5, then half the input will be multiplied by 0.5, which is a bit lower than and gives less volume. And actually 6 dB less volume. And if you multiply by -1, if it's on the lower side here, it's not diminished, but it is actually inverted, the signal. And only if you perfectly hit 0, it would be muted. And for this patch here, the idea is that the sound is coming and going in waves. It's not the idea that it's being inverted. That's not the musical idea here. So the polarizer can help here. You plug this bipolar signal in here in the polarizer, and there you can read B to uni. So that means bipolar to unipolar. And if you look at this now, you can see that only the positive range is being used for this signal now. Right. There's also another conversion from uni to bipolar. Don't use this right now. This would be distorting the signal. Or actually, I can do it. What does it look like? Yeah, it goes off the chart because if you fed a bipolar signal and make it bipolar, it will be too extreme then. So have to be a bit careful with this. But yeah, that's about it for this patch. You know about the binaural spatialization, how you can trigger it with the right joystick, setting tunes with a keyboard, transposing octaves with the quantizer, doing amplitude modulation. That's the thing. If you polarize it to uni, then it's not ring modulation anymore. It's AM. It's amplitude modulation. And generate evolving binaural chord scapes.